Another little process that is associated with cyclogenesis in a positive and negative way is called the Saharan air layer. We already talked about the easterly jet and the easterly waves, and we said easterly waves are often associated with cyclogenesis by providing the MCSs, the mesoscale convective systems. Here the influence of the Saharan air layer on the African easterly jet and on the easterly waves together can be considered on the cyclogenesis itself. So the African air layer is basically dry layer that is getting picked up, well mixed, and remains very much in the marine layer as it comes off of the continent. On here you can see the Saharan air layer extending all the way into the Caribbean, and you can see the image here showing the vertical sections of the African easterly jet and the convective systems that are sitting there with their lower level cyclonic feed into the convection. And the combination of the Saharan air layer and the easterly jet can either create cyclonic vortex to the southern side of this and advect it along and favor cyclogenesis, or there are also times when the heating and the heating gradient associated with the Saharan air layer can actually make the mid-level easterly jet much stronger, which means the vertical shear is going to get stronger, so it can actually suppress the cyclogenesis, or the survival and evolution of the incipient vortex, as we have been calling it. Okay, so it's a mixed story, and the main point will turn out that models which do not represent this very well, models often don't have this kind of process of lifting dust, mixing it up, and advecting along with the circulation. There are dust models which are specifically trying to put in sources and sinks of dust and then try to do this for various reasons, like producing dust products or looking at the impact of these dust on ocean productivity, because these dust storms tend to deposit some iron which is needed for the ocean phytoplankton bloom, and so on and so forth. But now there are methods of using satellite data like the GOES Meteosat here shown for September 2001, I think, and also, yes, that's about it. So you can see that there is a very well defined SAL coming out, and there is Erin, which obviously got named, so it became a tropical cyclone, and you can see how the SAL is interacting with SAL, and then Erin got pretty strong and got out of it anyways. Okay, so the exact conditions of SAL, easterly jet, African easterly waves. Okay, there are still African easterly waves along with the jet and the SAL, so you can see the easterly waves there. So the combination is going to be very complicated, especially for models to include them in the cyclogenesis and evolution of the cyclone. Here is an example of Diane. So GOES SAL tracking satellite imagery with overlaid GPS drops on points for Hurricane Danielle on certain time on 2019, August 1998. The yellow-red shading indicates likely SAL regions. So algorithms are used to derive these. That's why we call them likely, with increasing amounts of dust content and dry lower tropospheric air. So that's another thing we should remember, that when this Saharan air layer gets formed, it's very dry. It's not only dusty, but it's also very dry because it's desert air that's being entrained into the lower part of the atmospheric flow coming out onto the ocean. So this is the light circles indicate GPS zones dropped in the SAL environment. Dark circles indicate GPS zones dropped in non cell tropical environment. So this is outside the cell and these are within the cell. This paper also provides from AOML also provides some examples of time series of the track intensity for several Atlantic tropical cyclones during 1999 through 2001. So those are northern hemisphere, of course. Red shading indicates that TC was under the suppressing influence of the SAL. Green shading indicates periods when SAL was not impacting the TC. So you can see each one is a named storm, various intensities. We just looked at Erin. So either that means they survived the suppressing influence of the SAL and ended up coming out and intensifying in terms of the wind speed here. Okay, you can relate this to the Saffir-Simpson scale on your own. And some of them had a shorter influence of SAL. One of them, Hurricane Debbie, had basically remained in the influence of SAL the whole time, and its intensity remains relatively weak compared to the ones that came out. Same for Hurricane Debbie. Hurricane Joyce started strengthening and then the SAL seems to have suppressed it. Tropical Storm Chantal, weak. Hurricane Erin that we just looked at came out of the SAL influence and grew, had a good life cycle, and Felix as well. So this gives you a good sense that models which do not have SAL or accurate SAL, for example, tend to overestimate the evolution of tropical disturbances into tropical storms and cyclones. So when we are making predictions, if you do not include the suppressing effects of SAL, then you may systematically over predict the evolution of intense storms, which obviously has to be avoided. So we have to see what kind of techniques are used to account for SAL. Of course, one of them would be to use satellite data for SAL to prescribe SAL in the models, which are not explicitly representing the processes of formation of SAL. So we will see that later on. Okay, so another process, Saharan air layer, that can sometimes produce cyclogenic cyclonic vorticity advection by interacting with the easterly waves and the easterly jet, or sometimes its heating and temperature gradient can strengthen the easterly jet at the mid-level and suppress the evolution of the incipient vortex. Okay.